As I always say, forgive your enemies, but remember their names. Now, gentlemen, as I like to think, in the long history of the world, that there are only a few generations.
Sounds like someone breaking in!
It's just a storm, Dick. Sit down.
Oh my God!
It appears the Pentagon has been breached.
Zombies. Gentlemen, at times like these, our capacity to retaliate must be, and has to be massive, to deter all forms of aggression. Gentlemen, lock and load.
Viva la revolución!
It's the good times in COD back then when in zombies. But what about multiplayer?
Her bodies go like.
Or these?
UAV online. Tactical nuke ready for launch. Tactical nuke incoming!
The tactical nuke. Now, how does that relate to physics? Well, I'm not talking about the tactical nuke per se, but what if a nuke launched in the sky?
Kill confirmed. Friendly EMP systems detonated.
What you just saw right there was something called an EMP, or an electromagnetic pulse. Now, what an electromagnetic pulse is, you can think about it, it releases such a big electric magnetic field that it completely fries all types of electronics. Don't believe me?
Physical shock. But detonated miles up in the atmosphere, experts say, the main impact is electrical. Energy that doesn't kill people but spreads like lightning, striking any electrical grid or circuitry, feeding into them, burning them out.
Well, now you know the actual effects of an EMP. But what was wrong with that video before in COD? Let's go back.
Kill confirmed. Friendly EMP systems detonated.
What's the difference? Well, if you go back in the video, if you notice something, if an EMP disables all electronics devices, why does it disable the enemies but not the friendly teams? And it doesn't seem like the friendly team has any type of protection.
Hostile hunter-killer drone inbound. EMP systems online.
Now, EMPs can vary from many different types of things. You can even build your own EMP at your own house if you want to, but it won't be as strong in comparison to an actual electromagnetic pulse from a nuclear bomb. Like, for example,
against EMPs. Whoa, you see that? Starts going crazy here. Whoa.
now in that video by Everything Apple Pro, the iPhone internal actually has some metal like additions that can actually withheld a certain amount of voltage, but not the amount of voltage as an EMP. Like in his video, the EMP was around 500 to 600 volts, which was more than what the iPhone can actually withstand. So you could start seeing how the screen started jittering and it starts shaking like this, and how it just completely fell off. Now, I want you to imagine that, but with 15,000 volts. Now that's an EMP from an actual nuclear bomb. And let's think about it. Just in that video on how that iPhone was completely demolished just from 500 volts of electricity, how can your friendly teammates' electricity, like for example their phones and their communicators, and on how they respond with friendly EMP, how do they still work even with 15,000 volts per minute? As an example for an actual EMP used in nuclear forces. Hello, I'm up here. This is the only way I could get this ready. Now, we're going to be talking about the range of the EMP. and we're gonna be assuming that this is a type of nuclear bomb with enough megatonage on how it will be available for the EMP pulse, and we're gonna be looking at the line of sight on how it will cover the United States. Now, through the formula with the distance, extreme distance from the nuclear detonation, which is D, and also R, which is the Earth's location, like the Earth's radius of the actual location. Now, through R squared plus D squared and H plus R squared, we get this formula. Now, through this formula, the only way this works is if the height that is determined by the blast is way less than the actual radius of the Earth. If this was the other way around, it would not be working. Then we come up with this formula: D equals D squared, H equals D squared over 2R. Now, using approximate notes about on an average small nuclear bomb, we get D to be 2,500 kilometers, and then we get the radius to be 6,400 kilometers. Now we get the answer to be 500 kilometers. That is the range of an EMP. 500 kilometers. Think about it like a major circle of death. That's what you're in. Welcome. Now we're going to talk about the actual strength of the EMP. Remember when we were talking about that 15,000 volts per meter? Well, now here it is. Now, we're going to assume that an EMP is going to be used by a 1 megaton nuclear bomb. If it was something bigger like the Tsar Bomba, this would be far worse. But as for this our case scenario, we're going to be dealing with 7.6 times 10 to the 10 joules, which is still a lot. And the strength of the EMP is going to be used by the actual EMP value over 4 pi epsilon naught, which is the free space permittivity constant, times the noted Teslas, which is going to be 10 to the 6, all square rooted. Now, doing some math and some hula bully over here, we get the answer to be around 15,000 volts per meter. Now, give me an explanation on what 15,000 volts per meter is. Now, every meter you go, 15,000 volts of energy is being passed through. Now, as far as we all know, no technology exists on Earth that can withstand such a voltage, and especially not a Call of Duty character's microphone / their weapon scopes / anything electronic.
I am Thousand Head.